Permanent human presence on our neighboring red planet Mars may sound far-fetched, if not impossible, but not in the eyes of Elon Musk. The founder and CEO of SpaceX is hell-bent on lowering space transportation costs so that Mars can be colonized. Elon Musk has clarified his vision of establishing a permanent human colony on Mars, stating that we humans wouldn't want to be a single-planet species, but rather a multi-planet species. The overall concept is not to relocate everyone to Mars, but to reduce potential risks to human existence while maintaining a strong sense of adventure. Hello, and welcome to TechSpace. This video will take you on a journey through the possibilities of space travel and how 3D printing is gradually turning science fiction into reality. So stay close, because we're about to explore the world of 3D rocket printing. SpaceX is focused on developing its next big project, if not the biggest of them all, the Starship, with its Falcon 9 rockets and Crew Dragon capsules already sending astronauts into space. You may be wondering what makes this so outstanding. So what's the big deal? SpaceX's Starship is a decent rocket, but we're talking about the world's tallest rocket, a massive stainless steel rocket that stands about 475 feet tall. The spacecraft is intended for interplanetary travel, transporting people from Earth to Mars and even the Moon. And like all SpaceX craft, reusability is not underrated. SpaceX has been able to reduce the cost of space travel by designing reusable spacecraft. Endeavour, the crew spacecraft used by SpaceX to transport astronauts on NASA's first human mission, the Demo 2, was reused for launching astronauts into space on SpaceX's third crewed flight, the SpaceX Crew 2 mission, which took place last April from Florida. This spacecraft's launch, now known as Crew Dragon, marks the first time a Crew Dragon capsule has been reused for space travel. The Crew 2 mission is SpaceX's third human spaceflight. The second mission, the SpaceX Crew 1 mission, was launched on November 15, 2020, and returned to the International Space Station on April 28, 2020, to free up space on the ISS, which has only 7 sleeping pods. SpaceX has set a new record by launching 3 human missions in less than a year, with plans to launch the fourth, the SpaceX Crew 3 mission for NASA. SpaceX has been researching augmented and interactive design methods for engineers, with the goal of accelerating their workflow by manipulating 3-dimensional CAD files. Following up on Elon's tweet of designing a rocket part with hand gestures and then printing it immediately in titanium, Elon Musk unveiled a system that would allow him to design rocket parts like Tony Stark in the Iron Man film series, and that will be his new 3D gestural design process integrates breakthroughs in sensor and visualization technologies, modify computer-aided design more naturally. Musk demonstrated how the software works on a computer screen by grabbing, rotating, and zooming in on wireframe models of SpaceX's Merlin rocket engine. The process simulates sci-fi and makes it a reality for manufacturing and industrial production by utilizing leap motion and Oculus VR. And at one point he stated, "I believe we are on the verge of a major breakthrough in design and manufacturing, as well as in being able to take a concept from your mind and translate it into a 3D object really intuitively on the computer." One has to wonder if this 3D printed spaceship, once achieved and completed, will be reliable for traveling between planets. The company had demonstrated the reliability of their 3D printed parts several times through numerous launch tests, implying that 3D printed spacecrafts will be reliable. Going back to the year 2014 will help to clear up some confusion. SpaceX successfully completed its first flight into space using a 3D printed part. The Falcon 9 rocket launch was successful, and the body of the main oxidizer valve in one of its 9 Merlin 1D engines was 3D printed. Despite high vibrations, the 3D printed valve functioned normally, with the optimal level of high pressure required for the liquid oxygen, and it was able to withstand cryogenic temperatures without any effect. The Super Draco engine is another accomplishment worthy of mention in terms of the company's experiments with 3D printed parts. The thrusters on the SpaceX Super Draco engine were entirely 3D printed. The engine powered the Dragon crew spacecraft's launch escape system, as well as the thrust used by the vehicle to land propulsively back on Earth. All of these was done with pinpoint precision, and it has the potential to achieve the same escape and landing on another planet in the future if the need arises. A successful propulsive landing on re-entry is critical for reusable spacecraft and rockets. This has been difficult to achieve in the past due to the heavy materials used for crafting. 3D printing of parts allows for the production of lighter parts, lowering costs, and increasing the engine's thrust-to-weight ratio. So far, the success of SpaceX's space travel plan has been marked by a series of designs, trials, and design changes along the improvement timeline. The company's implementation of 3D printing of engine components has so far been able to reduce output time required, allowing it to effect required design changes geared toward improvement more quickly. Musk hopes that the promise of zero-G games and pizza will keep passengers occupied. It has to be fun and exciting so that people will be interested. Could 3D printing help to enliven a potentially boring diet for Mars colonists? We have certainly seen NASA investigate the possibility, and BHEX has since commercialized some of the work related to 3D printing with food. Musk explained how SpaceX manufactures their Draco engines using 3D printing after announcing the success of testing the Starship Raptor engine. 3D printing in titanium and Inconel allows SpaceX to significantly reduce fabrication costs. Using 3D printing, integrated cooling channels in the walls of the rocket engine chamber can be created, a process that would be a real pain using traditional methods. Mars may be a great place to go, but Musk will not be among the first passengers. On the first mission, the probability of death is very high. Jordan Noon, co-founder and CTO of Relativity and a veteran SpaceX propulsion engineer, notes that Relativity's vision aligns with Elon Musk's goal of sending humans to Mars. SpaceX's Starship spacecraft prototype delivers humans, while Relativity delivers the printers to make rockets. The idea is to return home using iron and other weldable Martian materials. Noon said that the improved version combines robotics, machine learning, and metal 3D printing technology, which is used to fabricate everything from massive propellant tanks to individual engine components. The printer head contains the majority of Relativity's intellectual property. Far-fetched? Perhaps. However, such a scenario would help address the numerous weight and consumable issues that currently make a human mission to Mars a one-way trip. The Los Angeles-based startup, which is expanding its presence at former NASA facilities, has announced the second generation of its Stargate 3D metal printer and production line. The upgraded printers, which will replace the original version introduced in 2016, are being installed throughout Relativity's 280,000 square foot rocket factory at NASA's Stennis Space Center. The combination of machine learning and metal 3D printing technology provides what Noon refers to as closed-loop control of the printing process, which is constantly scaled. According to him, the new printers are autonomously learning how to print rocket components as a result of the enhanced capabilities. In early 2021, the startup plans to launch the world's first 3D printed rocket from Cape Canaveral. The Terran 1 launcher can carry a payload of 1,250 kilograms. Veteran Rocketeers agree that it's not bad for a space startup. The launcher was recently upgraded with a 3-meter payload fairing, effectively doubling the volume it can hold. According to the CEO of Relatively Space, a startup that aims to do just that, producing and launching a rocket takes 60 days if the parts are 3D printed. Relativity is not the first company to introduce 3D printing into space. SpaceX has done something similar with their reusable rockets, and NASA is researching the spacecraft part that can be made more reliable and cheap using 3D printers. Printing rockets, including the Starship, will be a huge help for SpaceX to launch as many rockets as possible into orbit. Keep in mind that SpaceX must be ready to meet the next launch cycle so that astronauts, engineers, and scientists can be launched to Mars at the slightest chance when Mars is closer to Earth, known as the launch cycle. Manufacturing the cylindrical Starship takes a long time, so Musk should embrace 3D printing technology for increased productivity. Do you believe that a rocket made with a 3D printing machine will outperform a traditional-made rocket, in your opinion?